The first one is, and this is going to be like the question of the day because it's kind of been mentioned in almost every presentation, but there must be a reason the vendors caused this fork and fragmented issue. What fundamental issues is there with OpenBMC which caused this to happen?
That's it.
Yeah.
Um, I don't see it as a problem. I think if people are forking it and modifying it, it means they're using it. And they're using it in ways that the original authors didn't. I agree it would be a lot better if all those patches were contributed back upstream and integrated so that the next person doesn't hit those things. But I think the number of forks is more a sign of success than a sign of failure. Um, and the fact that everybody's here in this room. That wasn't a foregone conclusion 6 years ago.
Yeah, I think it does talk to the success. That's great. I think it does present challenges for system integrators, though. So, as an example, like Meta, we have systems from all vendors, right? And Microsoft, you have all vendors in your data center. And so when we have all these forks, it's do I take from ASpeed's fork this bit and from NVIDIA's fork this bit and this from AMD's fork this bit, and how do I put them all together into something that I can release and manage and deploy to my fleet? The Meta BMC team is actually relatively small for how many servers that we have in production. And we lean our ODMs a lot for development, but in terms of how many full-time engineers we have at inside Meta for the number of servers we have, I think people would be pretty surprised at how small and tight that team is. And part of the way we do that is because we expect consistency. We push on these vendors and say, no, you can't just give us a whole, but you can't tell us we're going to build on your fork. We're not doing that, right? We're not building on a fork. We've got to figure out how to take the components that you've done in a fork and integrate them with our standard tree that we're deploying everywhere. And so I think it's great that everybody's building on it, right? But it does having these different branches makes it a challenge for somebody trying to put the pieces all together. And I think that's the piece that I'd like to see improved.
I forgot to mention the third member of this team. Pravinash is from AMI. He runs our OpenBMC organization. I'll let him take a shot at this one too.
Yeah.
My bad.
Okay. So maybe this is from AMI point of view. Again, yes and no. Whether you wanted to go with the forking the OpenBMC and doing on your own or not, it all depends on your use cases, right? We work with multiple vendors, including OEM, ODM, hyperscalers, and CSPs, right? So how you are defining your release model, that will decide you whether you wanted to go with the forking model or you wanted to, take everything from the latest and you have a common code base for the platform that you support and then leverage from there. So, but ultimately at the end of the day, as long as if you converge with the community where the common code base and the features that are, maybe generic enough, that is platform and silicon agnostics, that is, properly landed into the community, and then you only keeping, these platform specific or silicon specific or your data center specific requirements alone on the separate, and remaining things, at least it is coming from the community, that's good enough to start with. So again, it's all depends on how you define your use cases and build your release model.
Yep. One more from on. Oh, you have more? Yeah, go ahead.
Make sure I have my thought. I'm sorry. Go ahead. Maybe I'll come back.
Yeah, come back to it. One more online, and then we'll take some from the audience here. I've got a few more online coming in too. This was originally to Ed, but I think it's pertinent to, again, everybody. And you started to, yeah, no, that one comes later. And you kind of addressed it, but you didn't maybe fully. So I'll let everybody. You said that the future will be USB connections between components. Ever thought about TCP/IP? I saw companies moving to TCP/IP to interconnect components, pushing it directly to every component. Example, up into the flash.
USB does TCP/IP. You can expose a CDC device. There are platforms that do this today. NVIDIA's HMC does that today at scale in a bunch of different racks. The physical transport, I think, is different than the actual protocol running on it. And I think the most important point, not that USB is the answer to everything, it's that there's a lot more data that's coming, and there's a lot more untapped data that we today can't really stream off the systems. And there's use cases coming for pulling all that data at scale, aggregating it, reducing it, etc. That I think are starting to get exposed.
Either of you have a comment on that one?
No, I do agree. Like, the TCP/IP over USB, if I remember, maybe Winston will agree. It's been kind of more than 10 years ago that we used in our AMI proprietary stack. Yeah, I mean, it's a protocol, and then link layer can be anything. It can be a kind of USB or PC unique or anything, as long as the device supports for the for the two device communication for transferring the payload between that.
So I've been building BMC like devices and servers for a very long time at this point, over 25 years, I think. I've seen, this exact pendulum of we need density, we need disaggregation. We've gone back and forth in my career probably 5 times, right? So I think when you pick a particular solution like TCP, for instance, I think that implies a certain amount of disaggregation. It implies a certain level of software stack effectively that you're going to have to run, that might be interesting in some cases and might not be interesting in other cases. So I think it's probably more appropriate to talk about, again, like you said, not the hardware interconnect, but what are the software protocols that you're running, right? I think in just the last generation, we've taken a bunch of devices that were MCDP or PLDM over MCDP over I2C, and we went to PLDM over MCDP over I3C, and now we're moving to PLDM over MCDP over USB. And we didn't change anything in the PLDM, and we probably had to change very little in MCDP other than the kernel bindings for that underlying protocol. So what the hardware interconnect is, hopefully we make that other people's problems on the electrical engineering side of things. And on the software side, we're working at the standards bodies and saying, this is a standard that's going to work for whatever our model is.
Okay, any questions out here? Yeah, we have one over there.
So one about the forking. My perspective, I mean, not necessarily connected to BMC. Like I said, I mean, I've been only 4 or 5 years in BMC. Is if you are a provider, like say, a hardware vendor or like chip vendor, it makes sense to go upstream because it reduces the cost of support. If you have multiple consumers, you don't have to keep supporting everyone. Like as long as things are in upstream, you get a free maintenance in case like a kernel, right? For example, there are tree-wide changes happen, right? Same thing happens with OpenBMC, right? So you don't have to be in line with that. But on the other side, like as consumers, like say Microsoft, it also becomes easier, if things are coming from upstream, but there is a different parameter, right, which is the time to market, right? We have to get the system out in the data center to serve whatever our needs, and that is where we are open, right? I mean, like whether it's just a hardware chip or whatever integrating, but also like software solution, right? I mean, they like AMI, right? I mean, if there is a solution that can help time to market, I think we are open, right? The other part was about TCP/IP versus PLDM MCDP. Like MCDP is sort of equivalent to like IP essentially, but it's not as feature rich or mature. For example, configurations are like IP in IP world. I mean, there is like autonomous discovery. I worked in networking, so I always compare the parallels. So the autonomous discoveries, etc., are kind of not there in MCDP. They need to be configured from user space. So probably, if we are looking at too much dynamism, I think probably TCP/IP networking makes sense, and there are protocols that have been around, right? Whether it's DNS or all other things, the ecosystem is there. But I don't know if it really matters in like a private network, right? So if it's like integrating, say, for example, NVIDIA as a HMC, right? We would rather happily integrate with protocols that are mature. I mean, use TLS encryption and whatnot, right? I mean, which MCDP PLDM may or may not provide that. It depends. So I would really like to see more discussions on this in community, right? Which way things should go. So, thank you.
So going back to the forking, I think you helped trigger what I was thinking about before. So yeah, I think part of why it's happened is that in some ways it's easy, right? Yeah, just thinking about the open source community versus inside Meta, right? How easy is it for me to write some code changes and deploy it internally, right? I get the way our process works, I get somebody on my team to give me a thumbs up and we push it out to production. And so as a developer, right, like your success rate is very quick inside your company, right? And the people that you're working with, the people that are reviewing your software. And so it's easy, right? And that percolates up even to management sees that, right? And sees that on the open source side of things, you've got to plan ahead. You've got to build some reputation. You've got to make those contributions. And so that's where it gets the impression that it's slow, right? Is that your pace of success is slower, right? It's naturally going to be that way when you're taking two very different development models. And so I think, you mentioned time to market, right? I think a lot of companies have taken a time to market approach of, I've got to get this out the door and I only have this many software engineers. And to make that happen, the time to market is to do what I need to do to get my product out the door. And unfortunately, that's, technical debt on other people, basically, is my perspective from Meta, right? Is that is pushing the debt onto my team, for instance, who has to not only get the time to market, and we're expected to, put our cluster into production before other big foundational model companies. But at the same time, my team has to support these systems in production for 7 years, right? And we got to be able to deploy security updates and all that stuff. And that's where, getting rid of the fork is the necessity from our end, because it puts an operational burden on us and every other cloud provider and every ODM that's trying to sell servers and all of that stuff. So I think a big part of where it's come from is it's just easy.
Do you have a question? Yeah. Right here in front, Jason.
I'm not even sure what my question is. Hope it just spurs some discussion. So we've been talking a lot about standards bodies, and a lot of stuff has been going on with the standards bodies in recent years. I think we'll talk a little bit about that in our talk also, hopefully discussion. And sometimes they make specs that, from our perspective, don't really work. They're not meetable. And so how we work with the standards bodies today, it feels like, I guess I don't personally attend any of the standards bodies, but I feel like it's each company just sort of decides whether they want to participate or not. And sometimes they make decisions that affect OpenBMC. Do we have representatives from OpenBMC? Do we need it? Is there a different way that we should work with standards bodies to have them mesh better with OpenBMC?
I'm going to get in trouble here. The Redfish spec meeting was between 10 and 11. Nobody there was here. Everybody was here. I was duking it out with them on chat about an issue that was literally just like OpenBMC had an implementation and they were going to go make it illegal or something. There's trade-offs and everything. If I look at the specs that OpenBMC does implement, there's not a single one that we implement faithfully to the letter of every part of the spec. And that's where I think OpenBMC is important. We're the implementation that actually functions when your spec body breaks down, or when your spec, or more likely, when your spec body doesn't understand the complexity of what they've now asked you to go implement. It is really easy, for example, in Redfish to say, oh, you should just support multi-part, right? No big deal, right? And it's like, if you look at the complexity in the parser, we have it now, but for many years we didn't. And like, there's weirdness in how you proxy multi-part parameters that I'm literally, as we speak, fighting with the standards body now. So I think that's OpenBMC's role, is to feed back those things back to the standards bodies and say, hey, your stuff doesn't work. Here's proof, because here's an implementation that doesn't work. If you think it works, go tell me what I need to change in the code to make it work. And most of the time, at least in DMTF, that works. They are slow. There are probably things we need to do in OpenBMC around like OEM commands and OEM parameters that we probably need to evolve within the standards. But I think we're the proof, is the way I would put it. Yep.
So I am not involved in the standards bodies at all. I know Ed is much more involved in specifically the Redfish one. I also don't participate in OCP, but Meta does. So that's kind of my background. I think there's kind of a tension between standards bodies and something like OpenBMC, in that the standards bodies are not responsible for any implementation. Right. And we are the reference implementation for a lot of those standards. So I think, it's just a natural tension there that, like, I don't think the OpenBMC community is going to like put together a committee that goes and represents us at DMTF. Right. I don't think that that's something that I see happening. But yeah, it's not scalable either. But I think, we have individuals that have said, hey, I think, I'm trying to pick, SPDM is really important to me, and I want to get SPDM done, and I want to shape the standard. And I think we have individuals that have said, I'm going to go work with that standards body to go make sure that something is there. The other option that we have is to treat OpenBMC as the standard, right? And it is, it's big enough that in some cases, maybe that's the appropriate thing to do, is to say, we're going to drive something, and then maybe we'll go to a standards body and say, hey, we did this, can we document it better, or something like that, right? An example that I can think me and Ed have talked about is around CPERS. So, I think it would be great, personally, if there's these things called redfish message registries. I think it would be great if libcper generates a redfish message registry for all the hardware errors that can come out of libcper, and we publish that on Redfish. And so is that something that we should go to DMTF and say, hey, here's all the things that CPER has, or should we treat libcper as the reference, right? Either one of those, to me, I care about getting stuff done. I don't care about white papers. And so that's why I just have a hard time going to standards bodies, is I've got plenty of things to do to get stuff done. But, like, that's an example where I think, if somebody wants to take that up and figure out the right way to do it, and, whether it's libcper being the reference, or us going to DMTF and say, here's a new section of the Redfish message registry that covers everything that libcper can do. At the end of the day, I don't care, right? I want it done. So it's just a matter of somebody has to step up and do that kind of stuff.
So question before I'll get to you in a second. How are conversations happening I mean, you mentioned start up the conversation, and the gentleman in the back when he talked about something. Is there, I mean, other than things like this, which I hope, we can continue to do, are there forums? How do you bring up topics? I understand how you contribute code and view code, but how do you contribute conversation to the
Yeah, so there's, I mean, a couple different avenues. Discord is where most of the active developers are daily. In fact, I think at one point we said you couldn't be a maintainer without having your Discord ID in a maintainer list. I don't know if that's still there. We did that in the IRC days for sure, but so that's an instant message platform that you can have conversations, and there are some people. The challenge with that is with all of the community engagements, I think some of the difficulty is maybe understanding who has, I don't want to use this word, but authority to make a decision, right? In some cases, you'll get people that will respond on Discord that they're not contributing anything, and whatever they said really doesn't hold any weight, but at least it kind of starts those discussions. Maybe sometimes somebody that does have more knowledge or authority will step in and say, no, that's not really where we're going. Here's the evidence of what we've talked about already. But Discord is kind of the day-to-day place. The mailing list is another place that's much more asynchronous, but I feel like sometimes those discussions stagnate out, or people just aren't interested, and so they don't respond to it. There is a design ultimately, like if you want to do a new thing, you need to write a design document for it, right? So starting a design document and then putting it in Garrett and then putting it on the mailing list and saying, hey, I got some ideas here, give me feedback. That's kind of where you need to go for something meaty. And then the last thing is there is the technical oversight forum. So out of all of the developers, someone mentioned earlier qualified developers. So we actually have some scores that happen in terms of if you contribute code, if you contribute code reviews, you can get points. It's a little bit gamified, but you can become a qualified developer. And the bar is actually purposefully fairly low, I think. It's on the order of like 3 commits or 10 code reviews, I think. Don't quote me on, don't tell me I'm wrong. I'm going off memory here. But that gives you the ability to then vote for the technical oversight forum, it's called. And those are currently, we have 7 developers that are part of a smaller committee that, when I say authority, that's probably the closest thing to an authority body. When there is, typically what we're doing there is when there's disagreements within the community about what a direction is, we'll make a decision about, do we need to weigh in on this? Do we not need to weigh on this? Should we just let things settle on their own? And then, if it's something that we feel like we need to make a decision, then we have a vote and we make a decision. So hopefully that covers everything. Yeah. I don't know if you got anything I missed.
Yeah. Nope, good answer. I think we had another question back here.
Thanks. We've talked about like upstream and downstream development velocity and about like the culture of merging things and getting things done like in some kind of timeline. And I don't think it's only a cultural thing. Like from my personal experience, it also depends a lot on the infrastructure. Like we've talked about the Azure DevOps pipeline, we talked about like stuff like that, and upstream Jenkins and stuff like that. And from my perspective, it's been like, okay, if you have a good infrastructure with end-to-end testing and modern trends like AI code review, for example, that are slowly becoming kind of state of the art for many software projects, it can get a lot faster to merge things, because if you have end-to-end testing, you can see that it worked at least once, it worked at least on this platform. And yeah, a lot of easy to spot errors. The AI coding, the AI review will catch those. And I was wondering if any of the big companies who are taking part in OpenBMC are considering like upgrading the community infrastructure to support those ideas.
I guess I don't know of any specific plans, I guess is the simple answer. I think there, I think it's great if we do some of those things. I'm not saying it like I don't think we should do those things. I don't know that, like Meta, for instance, doesn't have any specific plans that we're going to step up and implement something. But I think if that's something you have interest in, I can definitely connect you with some people that would be interested in working on that with you.
Roughly the same as my answer. I'm sure there's a lot of people interested in it. At the end of the day, somebody needs to go drive it and make sure it's correct and not adding more noise. I'm sure most of the people in this room have turned on some sort of AI code review in their systems, and at least in my experience, it still requires somebody to maintain that LLM system itself. It's not just autonomous.
I think from what you said, though, I think there's a fundamental question that I didn't address, which is testing good enough for the code base, right? I think you didn't quite say that, but you had this implication that, hey, if somebody contributes something and there's test cases for it and it passes AI code review, can't we just merge it? Right? Like, okay, fine. I was putting words in your mouth, right? But like, I think some of the things you said, maybe that's one end of a spectrum of where software development could go, right? And the other end of a spectrum is kind of a process we have right now, which is, it is developer heavy. It requires, people to give thumbs up or thumbs down on code, and we try to review every line of code. Could we shift more in the other direction? Maybe. I don't know. Like, I think as a community, we got to talk about what is the advantage or disadvantage of that. I think earlier Ed made a comment about the LLMs, the coding agents, and one thing that is good to have consistency because it makes the LLMs do the right thing. When you have inconsistency, they hallucinate way more, right? And so that's one of the things that I think the community review helps with. It's still not great, is getting that consistency in place. In the last 6 months, I had some disagreeing conversations with someone that was suggesting, well, if I as a maintainer, can't I just take my little component and go do my own thing, right? Like, why do I have to align things with everyone else? And one of it is partially about that consistency, right? Is that other people in the community should be able to step in. And now we also have to consider LLMs and coding agents, and can they step in and fix things? And so when you do things on your own, it is on your own. And then why are you part of the community, right? If you're going to be on your own, like GitHub is there, you can make your own code repositories. So, but in terms of, can we automate things a little bit more? Probably. I think it's dangerous to go way too far to that extreme. I do software development at different levels of the stack. I don't just work in OpenBMC stuff, right? And when you're higher up in the stack, more of it is throwaway. You don't care, right? Like, and so you can just say, yeah, automation, it passes, click merge. OpenBMC is traditionally more in the embedded space where we care about reliability. We care about things that maybe you don't care about at the other end. And so, I suspect many people would not be comfortable with, you got green signal, just click merge. So, but yes, you're right. IBM does have a continuous integration system where every commit upstream, they go pull that internally. They have their own simulation environment that's not even based on QEMU that they do testing on, and then they report back. My team at Meta is actually working on something fairly similar to that for the platforms that we support in OpenBMC as well. So there is an avenue there that if any other company here has a platform that they've contributed that they want to give the compute resources to be able to report back to Jenkins that, hey, I picked up this code commit, I applied it internally on some real hardware, and it still works with this set of tests. I think that's something that is great and that would be welcome to include.
Just bringing up a older topic. The standard situation for MCP has been pretty, I guess, pretty smooth. We're, I guess, considered now with the kernel implementation, the kind of reference implementation of MCP. So we're included in, while we're not directly participating in the DMTF MCR meetings, because they're an awful time zone for Australia. But they come to us for some feedback on various parts of the standard because we have the experience in doing that. So I think there's probably a model we could follow there a bit about providing feedback, but not necessarily driving the standards if we don't have that kind of mandate. So, yeah.
Yeah, I agree with that, especially thinking about some of the hardware oriented standards or things. Yeah, I think maybe I shouldn't say hardware oriented standards. I think there's a lot of value that some of the chip vendors could do to push those standards directly, right? In the last couple of years, some of the conversations when I've asked them, why did you do this thing downstream? It was, well, the standards body didn't have it, and we felt we could move faster by doing our own thing, right? And so like I would hope and challenge them to say, well, maybe that's fine for a generation when you're doing something completely new, but like go to the standards and work with them and come up with something. If the standard doesn't cover what you want to do, maybe it's time for a new standard, but let's make that standard, not just do your own thing on your own hardware.
Oh, yeah, I'm going to take a question online. Pravinash, I'll let you answer this one. I expected this one to come up too. How do you overcome the complexity of Yocto to get new people rolling on OpenBMC on new hardware? And then there's a second part to it. How can we be more efficient to handle multiple interlinked repos in OpenBMC Octal without the clunky patch layer until both repos can be synced?
Okay, so this is, I think, most common question even we are getting from multiple customers from AMI side also. One of the reason is like before OpenBMC, even either AMI BMC or any in-house BMC stack from the different vendors, that is very simple. Like the flattened source, the build instructions and the build also, it's kind of quick enough, right? So when they migrate from the in-house OpenBMC to the OpenBMC, which is based on Yocto, there are lots of learning curves occurred. And yes, there are complexity also involved, multiple meta layers, open embedded, Pokey. And then when you build also, it all depends on how you are kind of, structuring your meta layers. So in general, like Yocto, if you build, yes, so it will build all the modules from the scratch. Workspace itself will grow like anything, anywhere between 40 to 50 GB. So this is the kind of one of the bottleneck, and also the other technologies involved within that, right? So the documentation and training is important. That's what we are kind of helping other customers who are migrating even within our AMI itself, like from proprietary to the OpenBMC based product line. So we have to train them, like the same engineers, same system software engineers who are working on in-house, or they are the language C to the C++ or Yocto to non-Yocto, all those things, right? So there are materials available in the OpenBMC, but that is, I think, it's not good enough. I think we have to create a kind of more training materials, to give a kind of hands-on training, how they can easily, quickly translate from one to another. Yeah, that's what we are doing. That is helping them. We are getting enough positive feedback. Maybe those kind of materials may be created and also uploaded to the community for an wider advantages.
Any other comments in general on Yocto?
Me or
for anyone?
Not on Yocto specifically. I think there's some clunky things with Yocto. I don't know how you do a source-based Linux distribution better, right? Chrome, I can think of, Chrome OS is a source-based Linux distribution. I run Gentoo on my desktop at home, which is a source-based distribution, and Yocto, and they're all pretty similar in how you represent how to build a package. And I don't know how you do it better. It's just an unfortunate thing of how do you build Linux from source. Maybe AMI, if you've had something where it's like, yeah, we had something that was just nailed down and was really solid before, maybe that's where you could give some improvements there. I'd suggest, again, working with the Yocto team directly about how to improve Yocto if that's where the hangup is. But I do think with some of what you said that there's some tooling that we could do that would make some of those things better. One example of that is I would love to see the Jenkins server build Docker images that it's called the S-state cache, which is all those artifacts you were talking about, all pre-populated. So if I want to make a change for a system that's already upstream, I can just pull from the GitHub container repository the whole S-state that was built, an hour ago from Jenkins, and use that as my starting point. I use S-state quite a bit on my development environment. I know at Meta we use it for our continuous integration systems, and so if you're not making pervasive changes, you can get rebuilds pretty quickly with some kind of S-state structure. So I think probably a big part of it is like figuring out where those pain points are and having people that are interested at improving the infrastructure, improving the tooling, improving the documentation, those kind of things for everybody.
Okay, any more questions from the room?
This question is for everyone, but I think, Patrick, you referenced SPDM twice. Once you said like there were 3 separate submissions simultaneously. Forks, right? I mean, and with trying to do different things. At the same time, there was also the recognition that SPDM is important, especially from a BMC perspective, where it is a attestation use case is important use case that BMC has to address. How do you guys feel? What could we have done better as a community? Could we have anticipated this somehow and started working on it earlier, or at least given indications of us working on it, or at least have something out there that said we would like to work on this as a mission statement?
So the way the question's framed, I think is challenging for any open source community. Like, people come to us often and say, what's on your roadmap, right? Like, the OpenBMC community does not have a roadmap, right? What is the OpenBMC community? It's a bunch of developers on the internet, and it's all you people in the room and a whole bunch of other people, right? Like, whoever uses OpenBMC, you're part of the community. Whoever contributes to OpenBMC, you're part of the community, right? And so, like, we're not a company, right? We don't have a director that's putting together a roadmap. And so, all of it is, SPDM as an example, how would we have gotten that better? I think it was, in my view, those 3 different entities all had their own downstream work they wanted to do. They saw it as important, but they never said anything publicly about it. They just went and wrote code, right? And then they came back and then said, hey, we did this thing, can you take it? All in very close proximity, right? And so if instead of doing that, they would have 6 months earlier said, we think SPDM is important and we want to invest in it, right? Then we could have gotten ahead of it and said, okay, you 3 companies, get your developers together and, work together in public on it, right? I think, I heard a comment earlier about somebody saying they were going to structure code to be open sourceable. And when you talk about open source, the easiest way to get something into an open source project is to develop it in public with that group, whether that's the Linux kernel, whether it's OpenBMC, right? Like, when you go to them and say, hey, I did this thing, unless someone in that community really, really wants it and really wants to put the effort to make it polished and integrated, it's just going to sit there. And so when you say, hey, I did this thing, unless someone in that community really, really wants it and really wants to put the effort to make it polished and integrated, it's just going to sit there. And so when you say, hey, I did this thing, unless someone in that community really, really wants it and really wants to put the effort to make it polished and integrated, it's just going to sit there. when you go ahead and you say, I want to build this thing ahead of time, other people can say, I'm not interested in that. I don't really care. I'm not going to give you feedback. Or they can say, yeah, I want to engage with you. I want to make it work for my use cases too. Right. And when there's multiple people from multiple organizations that are all working together, it's much easier for the community to say, yeah, let's take that, because we see, there's interest, but we also see there's commitment. Right. What's challenging for somebody just giving you a bunch of source code is that they may disappear tomorrow. Right. Because you don't know what, there's been companies that have contributed pieces to OpenBMC, and then their teams just got axed, right? Portions of them got axed, and they just one day give a commit that says, sorry, I'm not maintaining this anymore. And so like then the community has to step in and figure out how to pick up the pieces, especially if it's something that people are building on. And so when we get multiple companies that all step up and say, yeah, I think this is important, it tells the community that there's going to be enough resources behind it that it's not going to be left to a couple people to try and pick up the pieces. When things get abandoned like that, our default policy is to decide either no one cares about this, so we're just going to archive it, which that means nothing, it can't be used anymore, basically. You can't make improvements to it. Or we sometimes reach out to the community and say, is anybody interested in this? And if no one steps up, but we know it's important, then the technical oversight forum ends up being the maintainer of it, which just puts burden on those key people, right? More burden. So, Jeremy.
We have the design docs repo under, well, designs folder under the docs repo, and that seems to be pretty underutilized. I think a great thing to do would be, if there's an idea or an SPDM type topic, then proposing something simple for that, and we can take it from there. It doesn't have to be complex, doesn't need to be complete. It's a starting point for the discussion and the consensus to happen. I would very much encourage folks to contribute design documents or just propose random things if that's where we're going.
The awkward part with that one is there is an SPDM design doc. It was approved a long time ago, and then everybody just kind of disappeared. Everybody went to their silos and worked on, if you think about SPDM as like 100% of a pie, everybody worked on the common 20% and then their 10%. And if you somehow mashed them all together, you'd probably get a reasonable solution. But no individual fork, including the one my company wrote, like solves all problems. And I think that's where we really need somebody to step up and say, SPDM is important. We're going to build one implementation that solves all problems, all proposed problems. And like, what? The doc's not even that bad. The doc is like, we're going to support redfish measurement on MCTP devices or something. Like, it's not like we can go add more requirements there, but like you got to build a stable base where we can just go add each SPDM requirement in turn. And there's like 4 or 5 use cases for SPDM, and realistically we need one implementation to own all of them, and there needs to be one. Like somehow someone tried to put me in charge of SPDM, and I said I have never read the spec. Like at the time I had never read the spec. Like I reviewed the design doc. I got very angry at the person that tried to do that. So I think really what we need is just somebody to own it, and to own it for the next 2 years, not for the next month. What?
Not specifically. Yeah.
Right. Yeah. Right. There will be a next protocol, I'm sure.
There are also available in Sydney. But that of 2000
like this kind of SPDM or MCTP or even PLDM kind of protocol, right? That's where that nowadays no device that is coming up without MCTP, right? So the work group has to be created in the community. I mean, including everyone's responsibility. For this critical element of the technology has to be, serialized and commonalized instead of going in a kind of, different silo mode. So there is a platform exists, but not using.
It's really building on this. Talking about not having a roadmap, some things I think we talked about, MCTP over USB is coming. We've talked about OBMF is coming. Is there something we should do in OpenBMC as a community to not repeat the SPDM fiasco?
Own it. Go build it. Go build one and like make sure everybody uses it upstream, right? There's reviews for SPDM today that like people on this panel have looked at and contributed to, right? Go put it on your platform and then go say A, B, and C don't work. Here's a patch that fixes that. Get it deployed at scale within your company and then say, okay, this works. Let's go merge this series of 30 patches or whatever the stack is now. Right? I mean, that's what you got to do. And then go to another company and ask them to do the same thing. They're going to find a different subset of bugs. Do that 5 or 6 more times, and your bugs are limited or small. Right?
Yeah. Hi, this is Jakpal. I'm also one of the top members. One common thing that I have seen is that when someone raises let's say a patch or a PR, especially in terms of design, people lose interest after some time. They don't do follow-ups and things kind of get lost over a period of time. So I think SPDM is kind of one classic example that we had seen. There was a design, there were no follow-ups, the thing got lost. So I would say if someone like one of those 3 different companies, they would have made an effort to, let's say, request at least a repository where the code would have started landing. It would have seen some, light of day. Now the things are moving because there are follow-ups, but I think doing proper follow-ups on the PRs would definitely help to, keep the ball rolling. Yeah.
Okay, so one more question online. It's going to be consistent with this previous line of discussion, which is inconsistencies between different versions. This one has to do with host CPU. And what are some common, rephrase this question, some areas of host CPU management, for example, CPU profiling, telemetry, RAS, hardware diagnostics, power and thermal orchestration, that you feel we need to, I mean, the answer is all of them probably, but what are the most important areas that we need to try and push for a common solution across the various CPU vendors? Ed's holding the mic. He's one of these.
So I think I would say IPMI is dead. Let's start with that, right? But what's next? So we talk about, you said CPU management, so I'm framing it in that sense. I don't know what is the replacement for IPMI still, right? The IPMI standard has been, the white paper last published was 15 years ago. I don't know what the last version was. It's been a while, and there's no plan on reviving it, right? But there, again, I don't know what's next. Is it PLDM? Is it RDE? Is it in-band redfish? Is it, I don't know, something else? I think part of it is we don't have a reference implementation for what's next, and we don't have anybody driving a reference implementation for what's next. And for that one, you have to do it at a BIOS level and a BMC level, right? You have to get, I don't know if it's I'm forgetting all the different open source BIOS packages that there are. But you got to get somebody that's wants to drive that end to end and come up with a what's next.
Yeah, I think it is a little tricky. Since the silicon architecture is not common, right? I mean, if you take x86 ARM from the different vendors, it has its own capabilities, and they wanted to support their unique features, all those things. Let's take a remote debug as a one feature. Intel AMD ARM has the features remote debug. How through the out of band we can debug certain traces from the silicon. Right. But how and what protocols, what interfaces used, and what are all the capabilities exposed by the silicon, that's completely different. So that's a one features, right? Similarly, telemetry or any other RAS management, that is also, since we work with the multiple silicon vendor, we know that it is completely different. So this is maybe one of the forum where silicon vendors maybe come together and see how they can solve this is for the ecosystem to make it as a more simplified for the system architecture.
Yeah, so you mentioned hardware debug, right? And what you said there, that's actually a big pet peeve of mine, that they're all different. JTAG is, when was JTAG standardized, right? But like hardware vendors got together and standardized how to debug chips, and there's a JTAG standard for it. You just named 3 vendors that are not working together in any way, and they all have pretty much the same kind of capability. They all have their own implementation that you have to patch stuff on OpenBMC to get it running, and then you have to run some backend software that they give you that's proprietary for them in order to debug their chips, right? And I don't know how we get them to change. That's part of why I think we're trying to get a bunch of people from the OpenBMC community together to try and put pressure on them, right? Every time I meet with all 3 of them, I say, why can't you come up with something, right? Even chip debug data, how you get the CPR data out and what they think CPR should represent is different between all the vendors, right? And so whether that's people within the OpenBMC community driving that standardization, whether that's developers at those companies contributing to OpenBMC and then going back to their company and trying to drive how do we make things more standardized, how do we make them more public, how do we make them more upstream first, right? Like we need people who are experiencing the pain of integrating all these things that are part of the OpenBMC community to also be helping to push those vendors, whether that's from the outside those companies or inside those companies, to come up with standardization.
Okay, very good. That might be actually a perfect question might be a perfect question to end on. Patrick's plea there. I hope everybody works for one of those vendors is going to try and push that forward.